In this video, we are learning or relearning operations with functions. So first of all, remember that a function is a relationship between two variables where each input, or x value, or domain, is paired with at most one output, or y value, or the range. Typically, you'll see it as f of x notation, but you can also see functions in y equals form. Adding functions, you just add them together. Subtracting, you subtract. Multiplying, of course, you multiply. And quotient, you divide. So make sure that you note the notation. We've seen this before. We're revisiting it. And then at the bottom, composition. We'll see that in the second video. All right, so we have two functions, f of x and g of x. We're going to first add them together, and we'll talk about the domain as well. So to add the functions, you just combine like terms. So when we combine these two functions, our negative 7x squared and positive 7x squared will cancel, leaving us with 12x that does not have any like terms, and then 2 minus 5 gives us a negative 3. When we're looking at the domain of a function, we have to also think about the original functions, not just the final answer. So if we look at 12x minus 3, the domain is all real numbers. But we have to also look at the f of x and g of x functions, but those domains are also all real numbers. Subtracting, same process. Negative 7x squared minus 7x squared will give us a negative 14x squared. The 12x, again, does not have any like terms. And then the 2 minus negative 5 becomes a positive 7. Again, look at the domain of not just your answer, but the two original functions. We already talked about quadratics. The domain is all real numbers, and that's what we have for our difference as well, so our domain is still all real numbers. Then the last one, remember, we can also evaluate the function at a value. Since we've already subtracted our two functions, we can just substitute this 2 into the answer we got for part B. So we get negative 14 times 4 is negative 56 plus 24 plus 7. And combining our like terms, we get negative 25. All right, so now we're going to multiply and divide our functions. So starting with multiplication, and actually this one we are evaluating it at a value. So you have two options. You can multiply the functions with the variable and then substitute 3, or what's going to be a little bit easier, you can substitute 3 and then multiply your answers together. So that's the route that I'm going to take. So this also equals, sorry, that should be a g, f of 3 times g of 3. So as I mentioned, that's the way I'm going to evaluate it. Substituting 3 into our f function, and then multiplying that by substituting it into our g function. So evaluating each of these separately, we get 27 plus 3 is 30 minus 4 is 26. Our second, 4 times 9 is 36, plus 3 is 39, minus 5 is 34. And 26 times 34 gives us 884. The second one, we are dividing our functions. So we start with the domain for A we don't have to worry about because we evaluated it at a number. So we'll look at the domain once we divide them. So for f of x, we've got 3x squared plus x minus 4 all over. G of x is 4x squared plus x minus 5. So in order to make sure that this is in simplest form, we have to factor both our numerator and our denominator. So in the numerator, what multiplies? We have to do the AC method. So what multiplies to negative 12 and adds to 1 would be a positive 4 and negative 3. In the denominator, sorry, not sure what's going on with my calibration. What multiplies to negative 20 and adds to 1 would be a positive 5 and negative 4. So we have to factor each of these by grouping. I will try and keep track of everything in my head. We would have 3x plus 1 times x minus 1. In the denominator, we would have something similar. We would have 4x plus 1 times x minus 1. So our x minus 1s would cancel, leaving us with 3x plus 1 over 4x plus 1 in simplest form. But now we have to look at the domain. So the domain of our two original functions were quadratics, all real numbers, but once we divided, we put one of those in the denominator. So before it was simplified, right here, this denominator is what we have to look at for our domain restrictions. So for our domain on this one, x cannot equal negative 1/4. X also cannot equal 1 from that term that canceled.